Hello friends, welcome to Maths Practice. Today we'll be discussing probability, which is the last chapter of 10th NCERT. This basically includes the classical definition of probability, which we will understand with the help of examples. And yes, please do not forget to subscribe to Maths Practice. Friends, probability is a very vast subject. There are multiple approaches to defining probability, which include the classical definition, empirical, subjective, and axiomatic definitions of probability. In general, the empirical definition says it is also known as experimental probability. This approach uses historical data to determine the likelihood of an event occurring. For example, if I say there are 80% chances that there will be rain in August, this is dependent on the previous year records. So this is called empirical definition. Subjective definition. This approach is an individual's measure of belief that an event will occur. If I say okay, there are 80% chances that a particular candidate will win the election, this is my belief. So it is called subjective definition of probability. And the axiomatic definition follows some axioms which define probability. There are some axioms based on which you can give the definition of probability. But what we are dealing here is just the classical definition of probability. So let us see what is the classical definition of probability. The classical or theoretical definition of probability. It is also known as a priori approach. This approach assumes that an experiment has equally likely outcomes. In our discussion, we will assume that all the experiments have equally likely outcomes. Equally likely outcomes means that, for example, if I toss a coin, the outcomes are head and tail and they are equally likely. Or if I roll a dice, the number appearing on it can be 1, 2, 3, 4, 5 or 6. All are equally likely. So we give this definition assuming that the experiments have equally likely outcomes. The classical definition of probability says that the probability of occurrence of an event E is given by probability of E is equal to number of outcomes favorable to the occurrence of E upon number of all possible outcomes of the experiment. What does this mean? The probability of rolling a particular number on a die, if I want to find that, suppose I want the probability that 1 comes on the die. So how many favorable outcomes are there? Only one outcome, correct? And total number of outcomes are 6, 1, 2, 3, 4, 5 or 6. So the probability of rolling a particular number on a die calculated using this approach will give us as 1 by 6. Probability of occurrence of 1 is 1 by 6. Similarly, the probability that 2 will occur, that is also 1 by 6. 3 will occur, that is also 1 by 6 and so on. Before going to the examples, let us discuss some important facts. The probability of an event always lies between 0 and 1. Means if E is any event, 0 is less than or equal to P of E, which is less than or equal to 1. The probability of an impossible event, like for example if I say the sun rises in the west, that event is impossible. So that probability is 0. And that of a certain event means if I say that the sun rises in the east, that is certain, it will definitely happen. So the probability of that is 1. And probability of anything else means probability of any event will always lie between 0 and 1. Another fact is probability of an event E plus the probability of an event not E, means E occurs and E does not occur. The sum of the probability is 1. Or in other terms, you can say probability of an event plus the probability of its complement, that is equal to 1. The sum of probabilities of all elementary events of an experiment is 1. That means elementary events means the elementary singleton outcomes which are there. Suppose if I toss a coin, there are 2 outcomes. So the probability, the sum of the probability of all the 2 outcomes over here is 1. You know that the occurrence of head, what is the probability? 1 upon 2. and the occurrence of tail, it is again 1 upon 2, and the sum of the probability is 1. Equally likely outcomes means each outcome has same chance of occurring. For example, as I said, when a toy is caused, head and tail have the same chance of appearing. Now suppose if I see an example, a driver attempts to start a car. The events that the car starts or does not start. These two events I cannot say they are equally likely. Why? Because there are many conditions due to which it may start or it may not. Like if the fuel is less, very less, it may not start. Correct? If the condition of the vehicle, the weather condition, all these things are there. So I cannot say that the events that the car starts or does not start are equally likely to happen in that scenario. But suppose if I have a trial is made, trial means a person who is under trial is made to answer a true or false question. The answer is either right or wrong. Now these are equally likely events because nothing else can happen. He is giving some answer. The answer can either be right or it can be wrong. So these events are equally likely. This is the difference between equally likely events and not. To understand probability, first of all, let us take some simple examples. Two coins are tossed. What is the probability that we get two heads? Now suppose when two coins are tossed, what are the possible outcomes? Head on the first, head on the second. Head on first, tail on second. Tail on first, head on second, or both are having tail. So there are four possible outcomes. If E is our event of getting two heads, probability is defined as a number of outcomes favorable to E upon total number of possible outcomes. How many outcomes are favorable for E? E is getting two heads. So only H, one favorable outcome is there. So our probability will be 1 upon total 4. Probability of E will be 1 upon 4. Example 2. Find the probability that there are 53 Sundays in a year, ignoring the leap year. We consider it is not a leap year. So we know there are 365 days. When you divide 365 by 7, 52 weeks and 1 day will be remaining. Now we want the probability that this day will be a Sunday. Okay. So now your favorable case is just 1, that the day will be a Sunday. Upon total how many possible cases? It can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday or Saturday. So the probability will be 1 by 7. Now can you guess what will be the probability if it was a leap year? The answer would be 2 by 7. The reason is leap year means 366 days, 2 days will be remaining. So there are two possible favorable outcomes. What will those outcomes be? Either the 2 days can be Sunday, Monday, or they can also be Saturday, Sunday. Two favorable outcomes and both have Sunday in it. So 2 favorable outcomes upon total 7 outcomes. The answer in this case would be 2 by 7. Example 3. A card is drawn from a well shuffled pack of 52 cards. Now you have to find some probabilities, but before that I think all of you are clear. I have given the 4 shapes. They are called in English spade, diamond, heart and club. Now we are having a well shuffled. Remember why well shuffled? The reason is because we want all the elementary outcomes to be equally likely. So the pack should be well shuffled. And we have to find some probabilities. First case, we want the probability that the card chosen is a king of red color. Now how many kings of red color are possible? We know 2 are possible, either heart or diamond, both are of red color. So both kings can be considered of red color. Upon total possible how many cases? 52 cases. So 2 upon 52 or 1 upon 26. I want that the chosen card is a face card. You know face card means either you have jack, you have queen or king. There are 3 and there are 4 different types of cards. So 4 3s are 12. Favorable cases will be 12 upon 52, which is 3 upon 13. The chosen card is a queen of diamonds. Queen of diamonds. So now it is specifically given diamonds and queen. So only one such possibility, which is favorable. So the required probability would be 1 upon 52. You want a spade card. Total there are 13 spade cards. So 13 upon 52, which is 1 upon 4. You want a card which is not an ace card. See, you can do it in two ways. Either not an ace card means how many aces are there? There are 4 aces and it is not an ace card. So remaining anything can be there, which is 48 and total 52. So 48 upon 52, which is 12 upon 13. Or like we have defined before, that the probability of an event plus not event is 1. Total probability. So if I want that it is not an ace card, I can say it is 1 minus probability of having a ace card. 1 minus how many ace card? 4 ace cards. So 1 minus 4 upon 52. That also gives you 48 upon 52 or 12 upon 30. Fifth case. Now suppose if you are given only 5 cards, a 10, jack, queen, king and ace of diamonds, which are well shuffled and put with their face downwards. So now we are given totally only 5 cards. From these 5 cards you try to choose one card. What is the probability that it is a queen? Only one queen is there, so 1 upon 5. Second, if the queen is drawn and put aside, what is the probability that the second card drawn is an ace? Now since the queen is put aside, only 4 cards are remaining. From these 4 cards, there is only one ace. So the probability that the second card will be ace is 1 upon 4. Example 4. A lot of 20 bulbs contains 4 defective ones. One bulb is drawn at random. What is the probability that this bulb is defective? Now this is very simple. Probability that the bulb is defective. There are 4 defective and total 20 bulbs. So 4 upon 20, which is 1 upon 5. Second case. Suppose the bulb drawn is, first thing in this is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? Now suppose if the bulb drawn in 1, means in the first case, is not defective and we don't replace, then in the second draw the number of not defective bulbs will change from 16 to 15. Why? Because if the bulb drawn in the first case is not defective, correct? So it is not defective, we are taking it out. So first of all, the total number of bulbs will become 19 instead of 20. And since the bulb drawn in the first case is not defective, that means all the defective bulbs are as it is. The non-defective bulbs have changed from 16 to 15. So now your required probability that when you draw the bulb from in the second case and the bulb is not defective will be 15 upon 19. Example 5. 2 balanced dice are thrown once. Find the following probabilities. First of all, we try to find all the possible outcomes or the sample space. Sample space is a set of all possible outcomes. Now, when 2 balanced dice are thrown once, what will be the possible outcomes? Remember, if you draw the tree type of structure in this, it will be very easy. For the first dice, you have 1, 2, 3, 4, 5, 6. If there is 1 on the first dice, on the second dice, what possibilities are there? Anything from 1 to 6. So you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, if there is 2 on the first dice, then on the second dice, again anything from 1 to 6 can come. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. In this way, when you go on, you will get how many outcomes? Total 36 outcomes. Now when 2 dice are thrown once, what is the probability, first case, that the sum of numbers on the 2 dice is 11. Sum of numbers is 11. Which are the possibilities? 5 on the first and 6 on the second, or 6 on the first and 5 on the second. So our favorable outcomes would be 2 and total outcomes we have just seen, it is 36. 2 upon 36 or 1 upon 18. Second case, that the sum of the numbers on 2 dice is more than 10. More than 10 means either 11 or 12. Only 2 possibilities. When will 11 be possible? If it is 5 and 6, or 6 on the first and 5 on the second one. And when the sum will be 12? When there is 6 on both of them. So the total number of favorable cases would be 3 upon 36, which is 1 upon 12. Third case, that the sum of numbers on two dice is a prime number. You know prime numbers are 2, 3, 5, 7, 11. For 2 possibilities 1 and 1 on both dice. For 3 possibilities are 1 and 2 or 2 on first dice and 1 on the second one. Similarly for 3 I have listed down, for 5, for 7 and for 11. So you can just see that the number of favorable cases are 15 over here and total are 36. So 15 upon 36 or 5 upon 12. Fourth case, the sum of numbers on two dice is less than 13. Correct? Less than 13, it is a certain event. The sum will definitely be less than 13 because maximum is 6 and 6 on both dice, which gives the sum of 12. So this is a certain event. 36 upon 36 is equal to 1. Example 6. A jar contains 24 marbles. Some are green and others are blue. If a marble is drawn at random from the jar, the probability that it is green is 2 by 3. Find the number of blue marbles in the jar. So first of all, it is given that total 24 marbles are there, out of which some are green and others are blue. Let the number of blue marbles be x, then obviously the number of green marbles would be 24 minus x. Now we are given a probability. We are given the probability that the chosen marble is green. This probability is given to be 2 by 3. And according to definition of probability, favorable events upon total number of events. How many favorable cases that the chosen marble is green? 24 minus x, because 24 minus x green marbles are there upon total 24. So 24 minus x upon 24 is equal to 2 by 3. When you solve this, you get the value of x as 8. And what was x? Number of blue marbles. Hence, the number of blue marbles will be 8. Friends, in this chapter, we have seen the classical definition of probability and some examples to understand it. Now, some more assignment examples. First one, 15 defective pens are accidentally mixed with 135 good ones. One pen is picked up at random. Find the probability that it is a good one. The answer to this is 0.9. Second one, a box contains 5 green, 8 yellow and 7 brown balls. One ball is taken out at random. What is the probability that it is first case yellow, second case brown, third case neither green nor brown, fourth case not brown? And the answers are also given. Remember, in all these examples, we are just following the classical definition of probability, which says that probability is equal to number of favorable cases upon total number of possible cases. Third example, a box contains 100 cards marked with numbers 1 to 100. If one card is drawn from the box, find the probability that it bears first one a single digit number, second case 2-digit number, third case 3-digit number, fourth case a number which is divisible by 8 out of 1 to 100. Similarly, fifth case a number which is a multiple of 9 from 1 to 100, and sixth case a multiple of 5. The answers are also given. Class 10 probability deals with some very simple examples on the classical definition of probability. Hope you have understood them. So please do like and share this video and don't forget to subscribe to my channel Maths Practice. Thank you.